on the finite projective plane. So last time we have proven the dual of theorem P.1. We shall now prove the dual of axiom P.3, which is our theorem P.2. But first, let me make some corrections on clerical errors that we have committed in our last proof. First, here we have, again, it is important for you to complete the list here. So you would have to complete all pairs of points in this list so that what we contend in the later part would be justified. The same is true here, okay, to show that each line is distinct. Here we have committed some errors. The sentence here is lacking. This one. The assumption should imply that at least 3 of these 4 lines are concurrent. Also, there is a grammatical error here. Lines L1, L2, and L3 have, not has, have a common point. Okay. So we see that this argument led us to a contradiction that is, if this is point P, then L3 would contain P3 and P. So since P is a common point to all 3 lines, L3 would contain P. L2 would also contain P. So we see that points P3 and P would have 2 distinct lines passing through it that would contradict axiom P.3. Okay? Let us now continue. We have here theorem P.2, the dual of axiom P.3. It states that given 2 distinct lines, there is exactly 1 point incident with both of them. Okay, let us now try to construct the proof for theorem P.2. So we see here that given 2 distinct lines, okay, there should be 2 distinct lines. So suppose L1 and L2 are 2 distinct lines. We just need to show that there is exactly 1 point incident with both of them, meaning there should be exactly 1 intersection. Okay, when we say exactly, there actually are 2 contentions here. Exactly, meaning there should be at least and at the same time at most 1 point common. Okay, at least 1 and at most 1 at the same time. But then, axiom P.4 assures that every 2 lines should intersect at least 1 point. we would go back to axiom P.4 here. Given two distinct lines, there is at least one point incident with both of them. So we say by axiom P.4 L1 and L2 should both be incident with at least one point say P. Okay, so what only needs to be shown is that there can be no more than one point common to both L1 and L2. So there should be at most one, at least, and at the same time at most one. So suppose there are two. Suppose L1 and L2 also are incident with another point let's say R. This implies that there are two lines, two distinct, because earlier we have stated that L1 and L2 are distinct. So there would be two distinct lines incident with the points P1, P, and R. But this would contradict one of the axioms. One axiom is that axiom P.3, which states that given two distinct points, there is exactly one line that can contain both of them. So this contradicts axiom P.3. Hence, L1 and L2 are incident with exactly one point, proving theorem P.2, okay, which is the dual of axiom P.3. So this video will just be very short because again the proof is just straightforward, an application of the direct application of the axioms. Okay, axiom P.4 and axiom P.3. Okay, so that will be all for this video. We shall continue with the rest of the theorems in our next video. Bye.